locked in Earth's vast forests was put to use.
We're going to be up right next to it.
time pouring down on us like an endless rain. Sometime in the next century, its immense power may be economically harnessed, and sunlight itself will become one of the real keys to the universe of energy. But today, a far different form of energy is coming from sun-parched regions of the globe like the Middle East. Stretching across the hot desert sands, massive pipelines carry petroleum to the edge of the sea. It is a supply that is not inexhaustible, however. Not as the global demand for energy, all kinds of energy, continues to increase. Most countries must depend on the uncertainties of imported oil until the big breakthroughs finally happen. But the world can't simply park its cars or turn off its lights until that day. We must continue to conserve and extend today's energy sources and develop a broad mix of alternatives for the future. Already, current supplies are being stretched through the use of heat-sensing monitors and other new systems which help increase energy conservation. At the same time, special oil recovery techniques are helping to bring older fields back to life. Even so, the world is continuing to diminish today's known reserves. The energy search must go on to help us bridge to the future. Out in space, eye-in-the-sky satellites scan the face of the Earth, helping to find new oil and gas deposits. On land, seismic crews record echoes to pinpoint new locations. The best hopes for finding major new supplies often lie in some of the world's most remote environments, sometimes miles below the ocean floor. On land, these great drilling platforms would dwarf all of the world's tallest buildings. In the ocean, they function as complex, massive island communities, surviving in often treacherous waters like the chilling, windswept North Sea. The deep water search is now pushing still deeper. Here, a new breed of remote-controlled ocean floor units can bring up oil and gas from once inaccessible regions. The job of transporting fossil fuels has its own challenges. Near the top of the world, at Prudhoe Bay, Alaska, is the largest oil field in North America. The Trans-Alaska Pipeline begins here. A $9 billion energy highway stretching 800 miles over and under the rugged frontier. At the end of the pipeline lies majestic Port Valdez. About 1.5 million barrels of crude oil arrive here every day, enough to meet the petroleum needs of nearly 7 million households. But even as these frontiers are explored, new technologies are being developed that one day may economically provide energy in the form of synthetic gas and liquids. Synthetic oil is already being produced from these vast Canadian tar sands. Oil shale, the rock that burns. Located in the western United States, it is one of the greatest synfuel resources of all. Mined, crushed, and heated, it could yield billions of barrels of liquid energy. Smaller quantities of synfuel may be derived from a pesky river-clogging weed, the water hyacinth, along with grains, recycled wastes, and other biomass resources. Coal, perhaps the most abundant of fossil fuels. It is mined primarily to generate electricity, a growing demand for the years ahead. And one day, it too may yield large amounts of synthetic oil and gas. Over 1/4 of the world's coal is located in the United States. That's energy equivalent to more than twice the Middle East oil supply. Sometimes coal is hidden deep in the earth. Other times, it lies near the surface. Here, the overlying soil and rock must first be removed to reveal the coal deposits below. Then it is replaced and replanted, a massive reclamation project to help bring the land back to life. Another environmental demand on coal is also important. While some is clean burning, some requires precipitators, wet scrubbers, and other new technologies, costly but necessary systems designed to reduce emissions to harmless water vapor. Other sources, even small ones, may also help meet tomorrow's growing demand for electricity. From the Earth's great underground cauldron, the power of geothermal steam. From the wind, age-old power to drive the windmills of tomorrow. From the restless sea, power from driving waves, tides, and changing temperatures. And from the awesome force of moving and falling water, hydroelectric power. Nuclear energy. Controversial, but still a significant source of electricity. Chicago, for example, gets more than half its electric power from nuclear plants. And around the world, France, Germany, Japan, and many other nations are continuing to develop nuclear power as part of their energy bridge to the future. Some countries are also moving ahead with a new process, the breeder reactor, which actually creates more fuel as it operates. Within 2 decades, nuclear energy will probably contribute about 1/4 of the world's electricity. Unlimited electric power for tomorrow. Is it a fantasy? A pipe dream? Scientists at Princeton and other research centers don't think so, as they inch toward the process of the stars, nuclear fusion. The challenge? To fuse hydrogen isotopes at temperatures exceeding 180 million degrees. The potential exists for a real breakthrough to one day harness this inexhaustible new energy source. From the sun itself comes another potential for the future, solar energy. 1 million Solar heating and cooling are already in limited use. By the next century, research will hopefully lower the cost of converting sunlight directly into electricity. EPCOT's Energy Pavilion provides a showcase for today's solar technology. More than 80,000 photovoltaic cells have been installed on the roof. When exposed to sunlight, they generate electric current to help power your traveling theater cars. So, in a sense, you've been riding on sunshine throughout our show. In our ever-changing world, the road to tomorrow's energy is indeed long, complex, and challenging. It demands the development and wise use of today's energy resources. It calls for practical and affordable new sources for tomorrow. And it will require the combined efforts of science, industry, government, and the public. Then we will indeed bridge to the future, to a world which one day may harness the entire universe of energy.
Ignition sequence start. Engines on.